Alrighty then, this is division using scientific notation, part 6 of 6. This obviously the last lesson. I was going to kind of teach this on the fly and show you how it works, but it turns out it took quite a bit of time, and the resultant file size, the MP4 file size, was just too big. So I'm going to walk you through. I chose to do 0.0079 times 10 to the negative 10. I'm going to divide it by 4200. And that was the initial problem. Of course, as I've said before, what I really would like to do is just deal with 79 divided by 42. They're both whole numbers, and they're nice, neat division. The numerator is bigger than the denominator, but just enough. But what I've got to be very careful of is I cannot leave the initial problem. So I'm going to change the way it appears, but never its value. The initial problem remains the same. It just looks differently, and it lends itself to the type of division we want to do. So here we go. How do we turn this beast into 79 over 42? Well, what we can do is this. The first thing I did is I took the denominator and multiplied it by 10 to the 0 power. That way I've got the power of 10, like base, both numerator and denominator. That gives me a lot of leverage right there. So, how do I turn this beast up here into just 79? What I've got to do is take my decimal point, which is right here. I've got to shift it 1, 2, 3, 4 places to the right. As I shift it 4 places to the right, that means my power of 10 must drop by 4. It drops 1 place for each shift. So this becomes 79, that's the numerator, the top, becomes 79 times 10 to the negative 14th. And I play the same kind of game with the denominator. That is, I take 4200, my decimal point is here, and I shift it 1, 2 to the left. And remember, as you shift your decimal point to the left, the power of 10 goes up for each shift. So this becomes 10 squared. 2 shifts here, that means 10 to the second here. So now all I can do is, remember, it's all multiplication, division, I've got the same base of 10. I can break this up and say that this is actually 10 to the negative 14 minus 2, because 2 is the denominator, the power of the denominator, I should say. And the result becomes 10 to the negative 16. There we go. All right, and what's left is our beloved 79 over 42. And let's do the division. Does 42 go into 79? Yes, one time. There you go, 42. The remainder, don't look at that 0. Don't you dare look at that 0. You don't see that 0 yet. The remainder is 37. Okay, fine. Does 42 go into 37? No. That means we're leaving the land of whole numbers. We get our decimal point right there, and we are going into the land of the tenths. And that tells us now we can put in our gimme 0, our placeholder 0, because we're in the land of the tenths. Well, you only get 1 0 for each shift down as you do your divisions, or as you divide. So this 37 becomes 370. And 42 goes into 370. I didn't know. I tried 8. I tried 9. 9 was too much. 8 was right on. So I said fine. I used 8. 42 times 8 is 336, which is there. Okay, great. Once again, don't look at the 0. Don't you dare. 370 minus 336 is 34. I'm going to go from the land of the tenths to the land of the hundredths. Now I get my gimme 0, a single 0 right there. And how many times does 42 go into 340? 8 times. And that turns into 336. Right there. Anyway, so I drop, don't look at that 0 yet. I do the subtraction, 340 minus 336, I get 4. And because I'm going to go from the tenths, hundredths, now I'm going to the thousands, I get my gimme 0. That's where that extra 0 comes from, right there, just 1. And we have a problem. Mission control, we have a problem. 42 will not fit into 40. So we're talking tenths, hundredths, thousands. In the thousands position, we have a problem. 42 will not go into 40, so we say there are no thousands. I want to be sure I'm right about this. There's your tenths, your hundredths, yep, your thousandths. You get zipoid right there, 0. So 0 times 42 gives you 0. And you drop it down, and now we're going to go from the thousandths to the 10,000ths. If I get that right, always double check. Hundredths, tenths, hundredths, thousandths. Yep, 10,000ths. Now we're down to 400. We've got that, give me 0. And we say how many times does 42 go into 400? 9 times, and that is 378. And the process continues. You do your subtraction. 400 minus 378 is 22. You get your gimme 0 because you're dropping down again another place. And that's 5 times, which gives you 210. Alright, so our answer at this stage, and you can see I've got a bunch of dots here, and I'll get back to that in a minute. But our answer at this stage is well, roughly 1.88095, blah, 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 times 10 to the negative 16. Why, look, there it is now. 1.88095, bunch of numbers, times 10 to the negative 16. There's a reason I have all these dots right here and here, and I want to show you, using the calculator, why. And explain what's happening, because it's quite important. So I'm going to shift the camera around, break out your Dramamine, because I'm going to make you nauseous, and let's take a look. Alright, first thing I want to do is shift this back into scientific notation, or scientific format. Blah, 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 blah. Don't worry, I'll get there. Scientific. And our problem is, our initial problem is 0.0079 times 10 to the negative 10th. We're going to divide that by 4,200. So, in general, I like to attack the numerator and attack the power first. So I'm going to do the negative 10 business. There is 10 to the negative 10th. And now I'm going to multiply that by 0.0079. There we go. And now I'm going to divide that by 4,200. That number looks strangely familiar. It looks like 1.8809523809523 blah 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 times 10 to the negative 16 power, which is pretty much what we got. But I want to use an old-fashioned pointer here, if I can find it, to show you there's something going on. Remember, we're dealing with a fraction, and a fraction's a rational number. And that means that either its decimal equivalent will either terminate or start repeating. So let's take a look. Certainly doesn't look like it terminates, does it? So where's the repeating pattern here? Whoops, sorry about that. Didn't mean to hit you. All right, 1.8809523 809,523, whoops, 809,523, 809,523, 809,523. Do you see a pattern there? The simple pattern is 809,523. That's called a repetend. By the way, it kind of reminds me of a song by Tommy Two-Tone, but you can look that one up, Jenny Jenny. Anyway, we've got the number 1.80, let's see here, I'll start again. 1.8809523, 809,523, 809,523 times 10 to the negative 16. Now let's go back and look at the sheet of paper. And my old-fashioned pointer got in the way there, sorry about that. Here we are. Okay, our answer is pretty much what the calculator gave us, 1.88095. We chased it out to 5 and we quit. But the calculator says, and of course, don't forget your 10 to the negative 16. People drop that constantly. I can't tell you the number of students that drop the power of 10 there. that will lose you some points. But anyway, 1.88095 blah 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 times 10 to the negative 16. From our calculator, we realize it's actually 1.8809523 with the repeating pattern starting right here. 809523, 809523, 809523, blah 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 blah. That repeating pattern is called a repetend, and above it there's a bar called a vinculum. Repetend and vinculum would make a great name for a band, but anyway. And of course, don't forget it's times 10 to the negative 16. Don't drop that off. Going back to all these dots, the reason I did that was I wanted to indicate that I hadn't found the repeating pattern yet, or a terminating point. In this case, it's a repeating pattern. I wanted to indicate that there was more work to be done, and I used lots of dots. I did not use 3. Same here, lots and lots and lots of dots. I believe it's the Europeans use, maybe the Japanese, Europeans, I don't know. Look it up. They use the ellipsis, which is three periods with 3 dots, to indicate they found the repeating pattern, or the repetend. And I didn't want to indicate that. I used the calculator to find the repetend, and I indicated it by the bar called the vinculum. And that tells you where it is right there, 809523, and of course times your 10 to the negative 16. So that's about it. If you have questions on this class or just general input, you can reach me at Alan_Speakman. That's ALAN_Speakman. That's the word speak and the word man, and that's at hotmail.com. So I hope this helps you with classes like thermo and thermodynamics and chemistry, physics, all those lovely things. And let me know. Keep me posted. We'll see you. Bye.